you.
I'm going to share the link now.
Okay.
Come on. Why am I the only one sharing videos now?
You should be proud of yourself, Ezra.
No, please. I'm turning it off right away.
Okay, so we are live.
Oh shit.
Yeah. So I should start by saying good afternoon to everyone, right? And good morning to you, Ezra. Yeah. So I think this is the first time we're doing forLoop on Hangouts. Essentially, forLoop. Just a brief background or introduction of forLoop. So the forLoop is essentially a result of people wanting to share knowledge, what they know, everyone in the tech community, starting with Nigeria and possibly going beyond Nigeria, right? And the maiden edition was in April, where people came together in the idea of to talk about application monitoring and things around that. And so far, we've gotten support from the community, support from people like Gigalea, support from IdeaHub, support from everyone, and everyone seems to buy into the idea. So following the success of that, we've decided we need a wider reach, not constrained by physical location or commute and things like that, for people to be able to join remotely. Yeah, so today we'll be talking about microservices. Here we have Ezra Olubi from Paystack. We'll be talking about the business implication, the reason, or essentially decisions that needs to go into place, I guess, deciding if you want to go into microservices. Omoloro, the man from One Credit, will be giving us some hands-on, essentially. You'll be talking more about what you'll be doing, essentially. And Toby, anywhere. Okay. Toby from, I'm so sorry, I'm actually in transit, and yeah, I will be going off and on, and Ridwan is the main organizer, will be handling things when I'm not around. So yeah, I'm getting out from the car right now, just to get things rolling. Ezra, can you better introduce yourself, your background? Everyone knows you're at Paystack, and everyone has an idea of what you've been up to, but maybe you can just tell us about the things we don't know about you. I know you have cats, so yeah. So can you just take over from there?
Okay. Yeah, I'm Ezra, and I'm a developer at Paystack. I'm not sure. I think maybe someone should lead this. I'm not good at talking about myself, except I'm being asked specific questions. So, yeah. I don't know if anybody can do the honors of asking me questions. I'll be very glad to answer them.
Ridwan, Laura, and Toby, do you guys want to take shots at Ezra? Hello, Ridwan.
Yes, I'm here.
Yeah, you guys should take shots at Ezra. Let's help him introduce himself.
So how long have you been in the software industry?
Professionally, 10 years. 2006, when I finished, when I got out of university. As an hobbyist for way longer than that, I think 16 now. Yeah.
Laura, Toby. If you guys don't have any question, maybe Laura should just go on and introduce himself.
Okay.
Laura, can you unmute your mic? No one can.
Hi.
Okay, great.
Hello, everybody.
Great. Do you want to turn on your video too, please?
Yeah,
Hi.
might as well, since Ezra is himself also. Alright.
Since
Okay, my
Ezra
name
is
is
what?
Omoloro Oyegoke. I
Just
didn't say
something
anything about
brief
you, Ezra, I'm
so
sorry.
we can get started with
Yeah.
everything.
So my name is Omoloro Oyegoke. I'm a software architect at One Finance Nigeria. I have worked with several web technologies recently. Used to work in e-commerce before moving into fintech, and yeah, I'm being part of the team that moved to the Microservice architecture where I used to work. So something that's really close and personal to me and these microservices that we're doing. When I'm not doing computer things, which is most of the time, I like to try and read and maybe play or watch basketball. So that's my life in a nutshell.
Okay, nice. Nice. Thanks for the introduction, Laura. Toby,
Thanks, Simon.
you?
Hi guys. Tobby Kuyinu. I am a software engineer at Konga. I pretty much work in the service-oriented architecture team. Build microservices every day, and yeah, I'm particularly keen about microservices because of the disciplined approach, structure, and the organization. It fascinates me, and yeah, I have a particular interest in microservices because I think it's the future of software engineering and software development practices. That's what I'm also going to be talking about today. Thanks
Okay,
very
thanks
much
a
for the
lot.
thanks. Yeah.
Yeah, awesome. So, just in case you want to reference us, my name is Yomi and Ridwan is on the side. Ridwan, I guess you'll be monitoring the chat or comments for people that have questions or have things to say to our guests.
Toby, you
So,
need to play your video.
well, if he's not speaking, I don't think he needs to put on his video anyway,
Okay.
except he wants to. Yeah, so Ezra, over to you. Yeah, it's your floor. I'm going to be going on mute now.
Okay. Yeah. All right. So I think I'm supposed to discuss the business justification of microservices. I think pretty much the reason why you should use them. What are microservices and why you should use microservices? So I'll just jump right into it. I did not prepare a presentation for this, so I'm pretty much just going to like run through an introduction and advantages, and then perhaps pitfalls to avoid as well. Yeah. So, can everybody hear me? Sorry, just
Yes.
to be sure I'm
Yes.
not talking. All right, jump right into it. I did not prepare a presentation for this. So, all right. So, yeah, pretty much uh, like Toby said when he was introducing himself and kind of and said what he liked about microservices being that it gives you this like disciplined approach to writing software and all that in a modularized manner. That's been the appeal for me myself, and it's pretty much like the how will I put it now, the central point to the whole idea of microservices anyway. And I think so. Technically, if you've been a fan of what's it called, separating concerns in your applications from the onset and all, this whole thing shouldn't be foreign to you. Uh, so prior to, I mean, service oriented, as opposed to service oriented architected products and all, I think the other side is what we call monolith, where basically every single concern of the application is organized into a single process. And I mean, when one thing fails, the entire application comes crashing down. Or also, if you have to say scale out horizontally, you're essentially scaling the entire application horizontally as well, including bits that probably don't even need to be scaled. So ultimately, it leads to a very inefficient use of your resources in the long run. And I mean, yeah. So let's just dive right to it. So yeah, I would say one of the biggest advantages of using microservices for me, and one of the reasons why what I'll classify as business justification would be this decentralized governance bit of things, where you technically can make use of multiple languages, uh, multiple paradigms, and all of that to build these different business concerns out. So, like for instance, let's just an hypothetical application, which is say like a store, for instance. Yeah, let me just an online store. It's something like Amazon. Yeah. So it has like an authentication component to it, which what's it called? Registered users and all of that coming through. It has like a cart component to it. It has like the product management side, inventory management side rather, and then the payments bit as well. So already in your head you can like kind of isolate these separate concerns out, and then maybe it also has like tracking as well, analytics and all, right? So being able to like see these different bits of the application and being able to write them in the best way possible, in the language that is just best for them. If there's a reporting component as well, you generate PDFs or generate whatever it is you have to generate at the end of the day or at the end of the week or at the end of the month and all of that. And you can, maybe you need that to be like as fast as possible, maybe write it in C or something. I know all of that as against, trying to like cram the entire logic of the application all into a language you've chosen from the onset, like, okay, so I'm going to write with PHP or with Go, and then you end up writing things that shouldn't be written with anyway. So that's like one of the biggest advantages for me. I know that one of the appeals. There's also decentralized data management as well. Like for instance, your reporting side of the application doesn't necessarily need to share data with, say, the inventory or something, because it is just what it is. I'm just trying to be hypothetical here, because when starting out, I didn't exactly pick out any specific products to use to describe this. I'm sorry about that. But yeah, we also have the whole idea, the mindset of starting to think of your product as actual products rather than projects as well. So it's easy to like fall into this idea of, okay, I'm building this product, I'm building out this product, and it is a project for me. So we are starting with the authentication layer. Now when we are done with that, we move on, and then we start the inventory management side of things. Okay, now we're done, let's move on, let's start working on the ordering system. And okay, now we're done, let's move on to this. And then you kind of take it as like a project that goes from like point A to point C from start to finish, as against actually having teams that are thinking of the best ways to make these different components work and all that. So that's also one of the advantages that microservices brings into your going the microservices route brings to your product as well. You essentially have dedicated teams focused on different parts of the product, and I mean, they can scale out the different parts or improve it as much as they want without and essentially improve the overall quality of the application of the product itself as they go on. There's also the bit of being easy to automate infrastructure, and you can deploy hundreds of changes, well, maybe not hundreds in Nigerian terms, but of changes to different components of the application on a daily basis without necessarily affecting the entire product itself. So for instance, we need to make this change to the authentication layer and all of that. The rest of the product does not need to know all of this because everything is well siloed and isolated. So you make this change, yeah, everything just continues working as normal. As long as the contract between the authentication layer and every other service that depends on it remains the same, everything works just fine. I know. Yeah, and yes, also there is a the whole idea of microservices being evolutionary. Now, this is easily one of the biggest pitfalls of implementing microservices. It is easy to fall prey to the what's it called, the craze of a new fad, and be like, oh, okay, yeah, now microservices is the next big thing, and also, you know, my next project is definitely going to be in microservices, and then end up splitting out your business concerns into different modules that aren't what exactly as logical as they should be. And this subject is actually one of like the controversial points as well. One of my favorite writers on the subject is Martin Fowler. He once advocated, I think this was like June last year, advocated for a monolith first approach, where you and then well, he gave examples of like most successful microservices architected products today started from like the concept of started from being a monolith, and eventually as they grew and all of that, then they scaled out and were able to like break out the different components as needed, because oh, okay, yes, we need to like scale this separately, we need to build this bit of the product in a more appropriate language and all, and then you should like take those components out, rebuild them as services that connect back to the monolith core and all that. And then someone else in his blog also, someone gets posted on his blog and wrote a counter argument to that, like, well, no, it's always better to start from a microservices perspective before. Sorry, if your end goal is to have a microservices oriented architecture, then just start out that way. I know. So, well, in my own case, I kind of had like this middle ground bit of things to it, and ultimately, I believe it's up to everyone to like understand their product, the product they're trying to build when they are starting out, in light of the individual components. So, like the same way I just roughly like just broke down the different components of this e-commerce store and all of that, you would know exactly how best your real product, not an hypothetical product now, is going to be used. What parts of it you expect to do what, and all, and then break all of this down. Think of how best to implement this. What bits of these components at the moment are core to the central working of the product. And then maybe you can like first build like a little monolith core of some sort, and build all of that together, put that together. Things like reporting, things like background jobs, and all of that already. Those are like red flags already. Building them into that core does not make sense. Just as spinning them off as microservices immediately from the onset, and then ultimately you end up realizing you've essentially built out a microservice architected product without, I mean, it's just, hello? Okay, yeah.
Ezra, it appears someone joined and
okay, yeah. I realized that, no problem.
Yeah, okay.
Anyway, yeah, thanks. So, long story short, anyway, that's kind of like my approach to easing into the thinking of building out with microservices. And I may be wrong. It is actually a subject of controversy, and I understand that. But yes, I believe that's kind of like the part of least resistance, because when you're running a business and all of that, you also do not want to suddenly have upset your entire development team by, you know, ramming something down their throats. But ultimately, if you have a stellar team in the first place, they should already have been thinking of proper separation of concerns anyway. So yeah, ultimately everybody wins, and yeah, so that's that. I don't know if there are any questions and all of that. So I'll be happy to take them. Yeah. Or even if you want to question anything I've said, like, no, that's not right. So yeah, let's do this.
Okay, so thanks for that, Ezra.
Yeah.
I was just when you were talking, I was just thinking about the background of most of our audience. Sorry, Ridwan, are you looking at the comments whether anybody has anything to say? Hello, Ridwan. Okay, maybe he's not there. But yeah, I was just thinking about the audience and whether they even understand essentially everything we are talking about, right? So speaking in terms of hello, Ridwan.
Yes, I'm here. Hello.
Okay, that's you.
Hello, you're me.
Oh, yeah. I don't have access to the chat. Do you think any of our audience have anything to ask Ezra?
Yes, they do have questions. And the questions
Okay.
are coming in.
Okay. Maybe we should do that first before I go ahead with the comments.
All right.
So over to you.
Click on the Q&A. You can see the Q&A button because you have control.
I'm on my phone, so I probably am not seeing everything you're saying.
Okay.
Okay. I've seen that. Yes.
Are you seeing the questions?
Yes, I've seen that.
Okay. Do you want to just go ahead and do it yourself, Ezra?
Oh, yes, sure. I guess that's fine.
Okay.
All right. So the first one goes and says.
Okay, great.
Yeah.
Okay.
The first one says it's better. You mentioned during your talk that it's better to start out with microservices. What is the minimum number of engineers, developers you think is enough to manage microservices for a medium product? Okay. This is taking us back into the hypothetical product realm and all. And so let me think of, I don't know, can someone just come up with an example of what a small product would be? And then maybe we can take it from there. I don't know.
What do you think about an inventory system?
An inventory system.
Yeah.
All right, fine.
I think that's something common, and people would probably be able to relate.
Yes. Yeah. All right. So let's see. A comprehensive inventory system will probably. Okay, wait, hold on. This is SaaS, right? Anyway, fine. It will probably have like what? Well, the authentication bit of things. The inventory management side of things as well. Perhaps an API to interface. Yes, reporting obviously. Also, perhaps an API to interface with a mobile component if that's going to be a thing with the product as well. So yes, let's do this. I think ultimately you can have just one person. You can have one person managing what's it called, each of the individual roles, and you can, if it's a small scale product, like for instance you are building this out for maybe like a single client or something, but then if you say that's why I kind of asked if it's SaaS from the beginning, right? Because that's kind of like how I can try to see this and reconcile it properly with
Ezra. So I actually have a better idea.
Okay,
maybe you should relate it in terms of what you do at Paystack. How about that? So maybe it would be easier for
you guys
to
want
answer
to
that
like make me drop some secret stuff. Anyway, okay, fine. I think that's easy. So like with regards to Paystack right now, we have the dashboard, we have the public facing APIs that everybody interacts with, and I'm talking in like very general terms right now. And then we also have the core banking layer, the banking layer that actually interfaces with the multiple processors. And now this banking bit has also like been broken down into what. So like to talk with InterSwitch, we kind of built like a wrapping service around InterSwitch. To talk to MasterCard, a wrapping service around that. To talk to the banks, we also have that too. So direct bank debit, Zenith, First Bank, all of them. We have something that is just written to talk to them. So ultimately, we kind of abstract all of this to the rest of the application that actually needs it. We also have like a logging service that we built. We've not opened this up yet to the public yet, but basically every API call that you make is logged and the response as well. So to make it easy for us to like debug issues when they arise and all of that. That's also a different service of its own, just running there. Yeah, that's so. If we're going to talk about the minimum number of engineers and all that, all of this is actually at the moment just being managed by 2 people. So yeah, but the mindset of it is like, okay, ultimately we are going to grow each of these individual. We are going to grow teams around these different bits of the product, these different services. But we are currently wearing multiple hats at the moment to make this work. So yes, that's that. I'm not sure if that answers the question well, Mr. Oyegoke. Maybe you can like just say yes or no or something. But anyways, the next question is also by Adegoke. By Toby Adeyemi. In building microservices, what design principles or patterns would you take into consideration? Well, separation of concerns. I guess that's.
And I think our other speakers will be talking more about implementation and how to think of microservices. So
yes,
I guess
okay.
You can wait for that.
That question can wait. All right, fine. From
Exactly.
a business, yes. From a business perspective, what would you say microservices? Would you say microservices save cost? I think in the long run, yes, because well, like for instance, with the example of Paystack that I just gave, it just gives you a much more granular understanding of how the entire product works without having everything jumbled up into like this big product that well, you don't know where to start from anytime it's time to like let's improve a functionality or let's debug something and all that. Everything is just all in one together. So it saves cost when it comes to cognitive, not bringing cognitive dissonance into your team when you start hiring people around these multiple services at the end of the day. And also even for you as a developer, you kind of see your application, your full product for what it is in light of its of its separate concerns. So I guess I don't know. I think that's just common sense. Yes. Would you say separation of concerns is the same as microservices? No, not exactly. Separation of concerns is one step towards building microservices. Not exactly the same. I mean, so far so good. We most of us build our apps with the Rails MVC paradigm. So we kind of already have separation of concerns in place where multiple concerns are separated into different controllers and all of that. But that's kind of like a good way to think of things. But this kind of separation of concerns, on the other hand, is kind of like on a higher level where, like I said, authentication. Well, right now you might have like your authentication controller just written out. and all. But ultimately, you might want to build an entire product around that as well. So if you have multiple products, say I'm going to reach here and just go ahead and say maybe a product like Google. Their authentication is the same across their multiple products. Whether you're using Google Plus, whether you're using Hangouts like we are right now, whether you're using Gmail, whether you're using something else, AdSense, some other product that they have, it's the same authentication layer that's been built for that as a separate product of its own. Once you log in, then every other product can like confirm from that authentication service, like, oh, okay, yes, this guy is logged in. This is his profile. This is what we need to use to like, maintain a session on this different, I don't know, wherever. So that's separation of consent is an important one, first step to beginning to think in the microservice architecture, but not exactly the same as it. What would you think about multiple language stacks with microservices, that is having stock in JS, Go, PHP? How many? These are too many. Should it just be the best language for the job? Yes, it should just be the best language for the job, really. It will be too early. I'm not sure it will be right. That's like a very subjective question to say, oh, having so many languages are too many. I don't know the scale of your entire product in question right now. But when starting out, for instance, you just think, oh, I can build this analytics system faster in Go. Sorry, not build it faster in Go, but it can run more efficiently in Go and all of that, as against it being run in PHP, perhaps because of XYZ reason, whatever reason that there may be. Just go for it. Of course, if the team does not have the strength to write in Go, then I think write in JavaScript or PHP for all you care. Nobody gives a shit. The different applications, the different services don't exactly have to know what language the other service is written in, as long as the contract between them is maintained. And also, yes, I think I've answered all the questions that I have up here. So
okay, so we're good now.
yeah.
Okay, so okay, I think that's fine. Since we do not have any question from the audience, does anyone from the house here have any question? Laura, Toby. Hey, Prosper, I see you. Anyone? Read one. Don't let Ezra go like this.
No questions. I don't have any.
Nobody even wants to argue with me. Let's do this.
Okay.
Anyway, that's fine then.
Okay, in that case, I believe Toby is ready. Toby. Toby.
Hi guys.
Hey Toby. Thanks a lot, Ezra. So you're still going to be around, right?
Sure. Shall I?
Okay.
I guess this is where I mute my. I'm sorry, I hide my camera, right?
Yep.
My video. All right.
Yeah, and mute too. And feel free to chime in if you have anything to say.
All right.
All right. Toby, over to you.
Hi guys.
Right.
So I actually do have a presentation. I'll be sharing that right about now.
Okay, great. So I guess you can share your screen, right?
Yes. Can you see my screen?
Oh yes. Beautiful. Developing, testing, deploying microservices.
Awesome. Sorry.
We're slowly right. Unglued.
Okay. So yeah, I'll be talking on developing, testing, and deploying microservices, tools, platforms, and services. for deploying and developing. So this will probably answer some of the questions that were asked earlier regarding specifics or not. Laura would answer whatever is left. So the first part is about developing microservices, and it takes into consideration the components. This is like actual hands-on development. It takes into consideration the components, the standards and best practices. Under the components, we have a few highlights, and the same for standards and best practices. So I'll start with components. The first component to take into consideration is the programming language. Someone asked about someone asked a language-specific question earlier. Really, what languages can you use to spin up a microservice, or what language can you use to build a microservice? The answer is any language, anything that can be deployed and can be used to build an API, essentially. Golang, we find these languages are usually common for a reason. Golang is commonly used. We have Java. PHP is used for everything these days. We have Node.js and Python. I put up this list of 5 because they are usually broadly representative of most other languages. Like Java could also tell you that you could also use C++ for that purpose. Golang tells you could use anything between Ruby and C. PHP tells you could use PHP, or you could use Perl, or you could use any similar language. And Node.js, JavaScript tells you, and Node.js and Python pretty much tell you can use Node.js and Python and Ruby and other languages that seem to conform to that. So yeah, for programming languages, you can use anything, really, anything. There's no specific requirements. Use anything that suits your needs and anything that matches your skill set. It's best and fastest way to get a microservice up. Moving on, we'll talk about the data storage. Now, just like the microservices language, the data storage of choice could be anything. Logically, you would expect to see MySQL, and it's not too distant cousin Postgres. With these guys, you have the typical monolith application data store that you're used to, but because microservices would own their data store and they will own the entire application. It's like an actual application, but it's very atomic in functionality. Meaning it actually does very specific tasks, and it alters very specific aspects of the process, like a cart service or an order service. So every data related to that particular process, or every aspect of that process, is stored in your data store. Now, while the more conventional ones are MySQL and Postgres and the MariaDBs and similar technologies, you would have instances where you would need to use unorthodox or not so common data stores, or data stores that you might consider supporting in nature, like Redis. Sounds like a big joke, right? Building microservicing with Redis, it's weird, but I promise you there are valid use cases for building microservices and having your data store, hell, maybe your primary data store as Redis. Redis, there are some microservices that might require a large array. Just imagine building something that uses a mapping, a location service, for example. You are talking of countries, you want to get the states under a country, or local governments in the states in a country. So you just basically pass in the state ID or the country ID and you get in. It's a very that's a very compact service. It does something very specific. And if you were to build that, knowing fully well that these values don't change regularly, and these values don't really require some, let's say, some processing or some alteration, or they're not as mercurial as other kind of data to store. You can caption that as one giant array of keys and values as arrays. So it's a country has states, states have cities or local government areas. Now, when you face such situations, you probably are thinking Redis. I mean, it's straightforward. I mean, MySQL might be overkill for that. Although there might be arguments against using Redis as a primary data store, even I have reservations on that. But yeah, if it's not so pivotal to business operations, well, it's probably worth giving a shot. And lastly, Elasticsearch, just like Redis, not in terms of functionality, but in terms of fear of making it a primary data store. You might have your reservations on that, but there are some purposes like analytics and basically statistical data crunching that you would find Elasticsearch serves you well. I know two services that we use here in Konga that use Elasticsearch as a primary data storage. One is they are both actually very analytical in nature. They give reports and aggregations, and we find Elasticsearch is best for such things. So it's also worth giving it a shot, depending on the service you're building. Most services use regular SQL-based databases, but for those that might have MySQL as being overkill, you want to explore Redis or Elasticsearch or MongoDB or whatever suits your purpose. But a microservice has its own data store, and it should always have 100% control over data. Moving on real quick, we'll be talking about libraries, packages, and frameworks. This is in context, this is as a part or a component of the microservice. Libraries and packages, you would always use this. They help separate concerns. For example, ORMs. Any PHP developer would testify to, actually any developer at all, any API developer or any MVC developer would testify to the fact that ORMs are incredibly helpful. They kind of merge models and repositories for you, and they provide just one interface, so you can always do wonderful things with objects. They also help devs focus on functionality, and you likely write some yourself if need be. Not every library or package or tool is required to be imported. Some are just internal to you. Custom error handling, for example, it's something you could quickly write. It's a one file, less than 200 line implementation. Frameworks as well. Frameworks are in this context. Frameworks in this context is just for the out-of-the-box API feature, mostly, because most frameworks come with API implementations in terms of interfaces and endpoints and routing and stuff like that that you probably don't want to, you don't necessarily have to get your hands dirty doing those. And for languages that have heavy frameworks, it's best to find a micro version. Laravel, the bulky Laravel might be overkill for this purpose, for example. Same with Falcon. I think Falcon has a mini framework. I don't see any PHP here. I don't know what you're talking about. Moving on. We're talking about the interfaces API. Really, there's nothing to see here. Just keep moving. But really, the interface is just an API as you know it, RESTful. Standards and best practices. So I'll be using, this is not like a solid use case, but the things I'll be saying will be contextually relevant to Node.js, but any developer would be able to see how it applies to his language of choice. First is your project structure. Now, this is not a hard and fast rule to anything. It's just recommended or something you would observe, you would encounter a lot. The project structure usually looks most of the time like this. It should have a README, absolutely compulsory. It's priceless. It's compulsory. It's necessary. You should not create a repository without that. A descriptive one at that. And then you have the applications directory, or however it is aliased. In there, you would likely find, in this case, you likely create, if you're using a PHP framework, you would probably have this, this will probably come with it. But in this case, you are likely to do this yourself. Config, where you have your configuration files, your dependency injections, your database configurations, and whatever it is. You have your controllers, the regular MC, there's no views here. You have your controllers, you have your library. In libraries, an example to put that in perspective is the custom library I said you might have to build, like your errors.js, which is supposed to handle, which is also provide custom errors and stuff like that. This is just like my style. You could have something else entirely handle that for you. Also, you have your models, you have your repositories. Most times they would both not exist together. A lot of times, if you're using an ORM module or library, it would provide a mashed up version just as models, and the repository details will be hidden, which is pretty excellent. You have your routes. It might be reduced to a file in config, or it might stand alone as it is represented here, whichever way you handle it. It is just your wrapper around the framework. If you're using a framework, it is kind of like a wrapper around that, and it's how you choose to implement it and extend it and customize it. And these are directories. They have subfiles under them. Services is what developers usually mash up in the controllers and seem to mix responsibilities between the controllers and the models. And that is how bad software is built. Services should actually exist in any API, not just microservices, and they should have very fixed responsibility. So a service is responsible for doing this. We'll actually talk about this soon. And then your validations. This is also one of the best practices. You should always protect your APIs. Your endpoints should be protected. So you should be strict with validations and you should take it quite seriously. Also, you might have a binary directory. Some languages are very binary centric. Others might be for Docker purposes or for custom scripts and stuff that you use to that would assist building and deploying your app. Database related operations, migration schema, seeds, that would also be sitting somewhere outside the applications directory. And the most important directory here would be your test directory. You're likely going to have a helpers directory under that, a regressions directory under that, and a unit test directory under that. So,
Hello?
Toby, I think you've gone off. Can you end the call and try and join again?
Yeah, Toby left, huh? Hello?
I think his connection has gone bad, so he has to end the call and join again.
Oh, okay. Okay. Good. Hello, Toby.
This camera has been really useful for us, hasn't it?
Yeah,
Hello,
he's
Toby.
gone off. He's coming back. He's coming back on. He has to call.
Okay, great. Yeah.
We're going for everywhere we go. The heat of the rainforest and the minus temperature of the hard water. We're good. I like water. Actually, just load everything. here. Yeah, yeah, we can take a picture on this and either put a SIM card in the camera or tether it to our phone and just take a picture and send it to Facebook, Twitter, Instagram, and cover it up there. Well, that's where this one's going.
Hello, Toby.
I'm back. I had
Okay,
a
great.
lapse in connection. I'm sorry.
Okay,
Where
sorry
did
about that.
where did
Can you get your slides back on? Can you get your slides back on?
yeah, where did I lose you guys? Do you have any idea where I stopped?
I'm sorry, I wasn't watching I know you were talking about the folder structure. I don't know this particular slide.
So
I'm
you
actually
talked about
get
your
off in it
custom.
now.
So you're talking about your custom. Yeah.
Okay. So I'll share my screen now.
Okay. Oh no.
Let me know when you can see it.
Okay, great.
Is it on now? Can you see my screen?
Yeah, I can.
Okay,
Yeah, it's
awesome.
on.
What did I hear?
Yeah, you're talking about tests, I think.
Oh, okay, yeah. So I said the test is probably the most important folder for me because in there lies all the validations of how solid your code is or how well your code works together, how put together your code is. I'll be talking about tests more elaborately later on. So moving on real quick to coding style. This is not necessarily a hard and fast rule for how you should code, but you'll find most of the concepts familiar already, and it's recommended you try as much as possible to imbibe um, the patterns that will be suggested. Also, we'll be using a Node.js use case. I'll be explaining as if to use Node.js, but you would always find how it applies to any other language. First, the proper documentation. That's programming 101. Is what we've always come to be told as developers. It's the first thing we are told to do. It's what we should always do. It's an advice that would never stop hearing. Always document your code properly. It's not only helpful for yourself in the future, it's also helpful for new devs to help pick up when they jump on a project. And you should preferably use an autodoc builder or generator. For Node.js, I use YUI docs, and it gives me nice interfaces. With this documentation, it will give me an interface more elaborate and HTML web page in nature kind of documentation. Also, you should properly structure your source code files. I said I would revisit the talk of services and models and repositories. So the services should contain business logic and straightforward functional tasks related to an entity. It should be clustered just like the models according to entities, but it should actually have more business-related rules, as I'll show you like code samples later. It should also abstract data manipulation and retrieval, but it should not directly implement data store. This can't be overemphasized. If you're not using a library and ORM module, you should definitely create repositories to handle that level of detail. You would also find out why in a bit. Your models should do exactly what the name suggests. They should model entities. If your model is not derived from an ORM, you should probably simulate one yourself, like a custom ORM kind of. And it's usually simplified like by ORM, as said already. So you should also connect your repositories to your model. Actually, your repositories should only be used by your models. Your models should only be used by the services. So the service is probably the confusing bit here for most people. but I assure you, you are probably overusing your controller if you don't adopt the service approach. And the controller should always be the entry point, and should simply coordinate the sequence of activities to be done by the service and decide at what points to return an API response. That's it. The controller is what interfaces with the route, is where the route sends a request, and it should not do too much. If possible, you should have a validation library and handle all your validations before getting into the code. Now, here's an example of a service. I'm trying to get the user data. I have provided the user ID to the user model. The user model gets the user. It gives me the user details and then the business rule. The business rule is if the user details exist, gets the addresses, append the addresses, and return it. If it doesn't exist, um, the API call should fail, right? So what I'm doing here now is I get the addresses. The business rule doesn't say the address must exist, so I just return it. So you see how the if else's should, all the if else's really should come here. It should be in the service, and I'm using the user model. I've used the user model twice. Now I'm assuming a non-ORM library scenario here. So you would see um, some implementation specific codes. So I want to assume we are not even using an ORM here. Um, This is like a pseudo code for, not really a pseudo code actually, not just code for getting user data. Let's assume that's a service function. It will be ideally it will be in a user file where all the user related services, service functions are placed, and that will be in your service folder. So moving on quickly, your model will simply talk to the repository. It would also get the user addresses, and you can see that it is just like a user data. It just surrounds the repository, and the repository is where you do the MySQL. And the interesting thing about the repository is you can see how easy it is to switch the data store.
I Toby.
Yeah.
Because of the timing.
Okay.
Just
Yeah.
sorry to stop you. I think we're already over 1 hour into
Okay.
the event
I'll
already.
round up the section and
Yeah.
almost
Thanks,
done.
man. All right. Cool. Great. Thanks.
So you see how convenient it is to switch off the data store. You could switch MySQL to Redis. This could be reduced to a simple Redis.get user ID, and the repository will be the only thing to be changed. So that's like an advantage of properly structured source code. Moving on quickly, you should always favor configurables rather than hard coding data. This can't be overemphasized. And then best practices, and then we'll rush through boundaries and limits. This is very, I think, just 2 slides. Best practices, you should have a base service to extend. In a microservice application, you would most likely have many services, tens of services, maybe hundreds, depending on how big it gets. You should always have a base service in whatever language or in the languages you use. This would make development very fast. You should use linting tools to ensure code quality. You should write unit and regression tests. Then you should protect your API. You should validate as much as you can. You should Dockerize your service. That's just an advice, a friendly advice. It's not production ready. And then the last section here would be boundaries and limits. A microservice must remain micro. Try to make sure you are suppressing concerns and not building distributed monoliths. It should be 100% responsible for its data. I mentioned that before. It must not be too dependent on other services. Sometimes it's absolutely unavoidable, but try as much as possible to make sure it isn't too dependent on other services. And it should preferably not be responsible for caching. Time will fail me on explaining why, but a lot of the time there are many layers of caching if all services are implementing caching. So yeah, we should try to avoid that. And it must not have unrelated models hanging around. That's just simply an indication of bad
separation of concerns. That's it. Um, questions?
So thanks a lot to that was really nice. So I guess it's let's see if our audience has questions. Questions, people.
Okay, I see some questions here.
Awesome.
I'll start from the top. Do you think it's efficient to use a centralized data store database in building microservices? No, you shouldn't use a centralized data store. You could host your entire let's assume all your microservices use Nightcore. You could host everything on one instance or one server, but you should have different databases for each of the microservices. Every microservice must be absolutely 100% responsible for its data. Data is uses and the data is manipulated. No external entity should be able to modify the data store for a particular microservice. And your microservice should also not modify the data store for another microservice. It should be 100% responsible for your data store and should be, yeah, absolutely internal.
Yeah, we have another question. How is the failure of one of many microservices managed?
What?
How is the failure of one of the many microservices managed?
Oh, okay. I didn't get to. I wasn't able to get there in my presentation, but when in the section of my presentation that talks about deployment, there are deployment patterns that would ensure. In fact, the concept of microservices is so the failure of one doesn't affect everyone, but there are deployment patterns that would ensure that it is impossible. The microservice being down just means the service is being down. If it is properly consumed by clients and consumers, front enders, then it shouldn't affect. Imagine doing a product page and the written service is down. The image service works fine. The price service, the catalog service works fine. The product description service works fine. The cart service works fine. The order service works fine. Everything that the customer needs to actually place that order works fine. But the ratings and review service is down. Ratings. Should that stop an e-commerce transaction? No. If the customer sees the product and is happy with it and is willing to buy it anyway, should be able to proceed with that. A monolith would break in that situation, but a microservice will simply say, we have a problem fetching the reviews right now, but yeah, here's the product, this is the price, and here you can check out. So if it's properly deployed, if a proper deployment strategy is used, then you'll probably have no issues with it, the service being down. Yeah, that's pretty much the
there's a question that says, you said the
I didn't get you. You're really on mute. But I see a question here that says,
oh, okay.
How do you share common configurations among microservices? Every microservice should have its config files. Depending on deployment pattern, if you're using let's say, multiple service instance in one container or in one EC2 instance, for example, let's use Amazon as an example, AWS as an example. If you are hosting like one instance of many services each, in one particular EC2 instance, then you probably would need a proxy pass if they are all implemented in the same language. If they all use the same technology, like Node.js, for example, you probably need a proxy pass, and then that's where the cost efficient thing comes from sometimes. Sometimes it's more cost efficient to have just one instance and you can also you need to make some compromises and you have to manage them separately. The configurations for each of them should be managed separately for your but your recipes and your deployments can be pretty much almost centralized, as close to decentralized as you can get. I hope that answers that.
Okay, you got that. All right. So there's another question that says, should you host multiple microservices on the same machine? How do you secure the service? What auth method do you use to secure the services? Example, digest authentication or.
Okay. Sorry, I
Personally,
couldn't
I
get
actually think
that.
that question. I actually think that question is depends on your product or your service. So ideally,
Yes.
this is just me coming in, right?
Okay.
So in my opinion, maybe if yeah, also it depends on what your team thinks, right? Some people would never use basic authentication for XYZ reason. Some people will say if you use basic authentication behind HTTPS, you're fine. So I don't. The question that the person asked
Okay.
about whether you
Am
should
I
use
get to share
digest
my
or whatnot.
slides at some point?
Yeah, yeah.
Okay. So those kind of questions are actually answered in the microservices deployment part of my presentation. So if I'm going to share my slides at some point, then yeah, yes.
Yeah, to be everybody's slides will be shared with everybody that's part of the forLoop meetup after the call. So everyone will definitely get the slides.
Yeah, it's, most of these questions are answered there. Um, I said that as a microservice should not depend on another microservice, but when I was reading that out, I said should as much as possible try not to depend on other microservices. There are lots of situations that the best architecture and the best design will still call for that to happen, but your primary aim when designing a microservice should be it should be 100% responsible for its implementations. And by depend on another service, I don't mean use another service. I mean depend on it. If the output of this microservice is mad or like output of another microservice, then if you look at it holistically, you're actually talking about a distributed, a monolith that is just.
Sorry, Toby, I think we've lost you again. Yeah, can anybody else hear Toby? Okay. Okay, it seems like Toby's connection has gone off again, but yeah, like he said, his slides will be shared after this call, and then any other questions, we can open a discussion on this, about this on meetups after, and just continue to talk about it if we have specific questions. I guess I'll go on to the final presentation for today, which is on communication between microservices. It should be a very brief one because we only have about 15 minutes left. Okay. Um, Let me know when my screen is displayed, please. Okay. All right.
Yeah, it's visible now.
All right. All right.
So
Thanks. All right. Cool. Thank you very much. All right, microservices and communication between microservices and with clients and microservices. That's basically what we're about for this section. So the story so far, we've talked about what a monolith is, kind of a system that has everything together. And then what happens generally, and I'm building from something that Ezra mentioned in his talk. We have talked about how Martin Fowler and some other people advise that you start with a monolith and then build out a microservice, because many times you understand your business better, you see functionalities that could be separated out when you have an initial monolith. So let's hypothetically have a monolith, and then we split it out into a client application and a web service. That's just two different parts, which most people do anyway. But most people don't even start from a true monolith. They start with a system where you have the client, and then you have the client app. It could be a web app or a mobile app, and then you have the web service. And then the web service gets split into several smaller units, and then eventually gets split into microservices, each of them handling an individual process. So the case study here will be e-commerce, because that's the industry I'm most familiar with. So just put some popular e-commerce companies in this area online. Yeah, I don't know why the Konga logo is so big, but anyway, moving on. So we have a monolith here. Let's call it superdupermall.com.ng. It would have been superdupermall.ng, but .ng domains are so expensive, so we had to use .com.ng for this one. So it's not just all gray. It actually has some things in it, some basic things you expect to find in an e-commerce website. So you have a homepage, you have the search functionality, category list, product information page, you have the cart, checkout, and then you have the user accounts page. So of course some pages are missing, but let's just keep it simple for now. And then in reality, you need a backend as well. You need a content management system for your different pages. So there's probably going to be superdupermall.com.ng/admin, and then you see the CMS page, you see the inventory management page, you see the order management page, and the customer management page. So if you have a customer that's always canceling his orders when they get to him for pay on delivery or something, you can flag him there and do all sorts of things, increase the stock of your products from the back end, and then see how many orders have been placed, just management things from the admin section. But it's still a monolith because everything is still together. It's still the same system. You still have to deploy everything together. You still have to monitor everything together. And if it comes crashing down because maybe somebody left out a semicolon in PHP, or you don't have forever on your node and it crashes, then everything is down. So, but taking it a step further now, superdupermall.com.ng started as a website, and all you had was the web pages. But then the CEO, after meeting with the investors, decided that, hey, we need a mobile app, and we need a mobile app now. So what do you do as the engineer of superdupermall.com.ng? You start building a mobile, maybe an Android app, because you're in Nigeria. Most people use Android anyway, and you build an Android app, native Android app. And then you need the Android app to be able to do all the things you can do on superdupermall.com.ng, of course. So you have to have some sort of middleware kind of service in between. So we call it api.superdupermall.com.ng. And quite many times, if this flow was followed in a real-life scenario, the API will probably initially start off inside the main code base of the superdupermall.com.ng. So you have the part that serves the front pages and the client, the web pages, and then you have the part that handles web requests. But then in many other cases as well, it's split out entirely. So you have the API in between. It's a green box, well, I mean a black box, but the background of my slide is black already, so you wouldn't have seen any box at all. But let's have that green box here, and then you have the mobile client connecting to it, and then the web pages connecting to that as well for the different things that they need to do. But what's inside this? What's really going on? You have the home page that has CMS, the CMS that has to deliver the static content. You have recommendations for, like you'd expect in a typical web, a typical e-commerce site, featured products that you want to promote, maybe the products of the e-commerce company itself, or products that sellers are paying to have featured. Then you have deals. Almost everybody does deals. Amazon does deals. Alibaba, Konga, Gmail, everybody does deals. And deals, of course, does deals. But, okay, and then you have the detail pages where you have the name, description, the images for the for a particular product. So let's say somebody has searched for actually listing pages should come before then. So somebody has searched for mobile phones, for instance, and he sees recommended mobile phones. Maybe the new Infinix phone or a new Apple phone, and then he sees that, he clicks on it, and then goes to the detail page. He sees the name, the description, the image, the price. He also sees reviews, and he sees recommendations and other things like that. So, I mean, a lot goes on. Seems simple on the offset, but then you see a lot actually goes on in a simple e-commerce system. You have the account pages for the user as well that have the order history information, wish list, cards, coupons, just the things that you do to keep your customers happy and make them keep coming back. So inside our black-green box, we actually see some of the things that are going on here. So it's not just a simple API. You have, if we were to break it out into individual services, we would have a product service, we'll have a rating service, we'll have an order service, customer service, stock service, card service, which is, I mean, it goes on and on. So many different services that can be decomposed in e-commerce. And I think e-commerce is a very good place to show this, a very good type of case study for this, because most of us are familiar with e-commerce systems already. Many of us shop online, and e-commerce is something that we can really think about in terms of having distinct units that need to be separated. So this is actually what's going on. We had the previous slide that was similar to this, but then this is actually what's really going on. You have many different calls being made between the systems, because to display a product detail page, you're not just calling product details anymore after you've broken out into your microservice. You're calling the product service to get the product information. You're calling the rating service to get the ratings for that product. You're calling the stock service to see the product is still in stock, to show, hey, there are only 3 more of these items, of this item left. Hurry up to get the hurry up before it's out of stock. You're showing the wish list service. If the customer has maybe likes the product before, has wished for it, maybe you show a heart on the side or a star that's filled in, saying, hey, you've actually wished for this product before. Here's a chance to buy it. So I mean, so much goes on in displaying that page. So I mean, for the web, you see, I mean, we're used to that on the web. The mobile app also has to have a way of fetching all of that. So yeah, this is showing what we typically have in web browsers. In fact, when you read the RFCs and the follow the mailing lists for some of the browsers, you see that they talk about these things. Web browsers are made to handle multiple requests efficiently, and that's what they do. It's no web page I know that I can think of actually doesn't have at least a few dozen requests. And that's how the web is. So we're used to, we're cool with it. We don't even notice most of the time that too many things are going on under the hood. But it's slightly different for mobile, because a mobile phone may not, it's probably not on a Wi-Fi network. It's you're on 3G or, God forbid, 2G, moving around and trying to do many things on your phone. You want to use Snapchat, Instagram, and you're trying to shop as well. Each internet connection, each connection you're making to be as simplistic as possible is trying to make a connection with a cell tower, and it could be a different tower if you have 2 or 3 very close to you. Each packet that's been sent, each connection has been negotiated. Could be with trying to find out which cell tower to use, and each packet you're sending also has the HTTP data being transferred with it. And for mobile people, when you're using your laptop, most of the time you're not really concerned with the data you're using, but on your mobile phone it's a whole different ball game. Another thing is mobile networks are unreliable, and then TCP requires that packets that it does not understand well, that get lost, be resent, and then you're just using more and more of your customers' data. Customers are very, very miserly with their data for good reason. It's getting pretty expensive. And then you don't want to kill the person's battery life, because the user that's using your app has to, I mean, his phone has limited battery, right? And you do every request that he makes is using some power to transmit the electrical pulse to the cell tower. And the more requests that have to be made, the more power the device is going to use to make the transmission. So what do we do about it? We could introduce something like gateways, which is the aha of this presentation, because I'm going to talk more about what happens between the client and the service system, and not really very much on what happens with communications between the services, because that's a very, very different ball game, and really depends on the use case and what you're trying to accomplish there. So what do gateways do? They drastically reduce the number of requests that are made. They allow efficient handling of retries, circuit breakers, and fallbacks for services, and they facilitate proper caching strategies. I will touch on each of these and probably go into more detail on the first one. The rest of them are self-explanatory or too complex to go into the limited time we have for this talk. Okay, so to drastically reduce the number of requests, I talked previously about, say, a product detail page, and then if we're going to break it out into microservices, a simple product detail page for a mainstream e-commerce site today would have an endpoint to get product information, to have one to get seller information from a rating system, to have one to get maybe cart information, because you always want to display the user's cart on almost every page on an e-commerce system. Probably it's going to get the user wishlist information as well. It's going to get recommendations, because you don't want to just display the products the person is viewing. You want to upsell or cross-sell or whatever recommendation strategy you're doing. And it's going to have maybe at least 4 or 5 services. I mean, that's at least 4 or 5 microservices that it's communicating with. So if instead of having to communicate with each of these services individually, you made it possible to kind of, without having a monolith, but to batch all the requests together and get your response back at once, then you would be doing your clients a whole lot of good. The next thing it does, it allows efficient handling of retries, circuit breakers, and fallbacks. Sorry for that. Okay, it allows efficient handling of retries, circuit breakers, and fallbacks. So one of the things to be mentioned in his call, and one of the questions that was asked is a very good question. What happens if one of the services fails? So if you have a gateway in front of your service system, you could say, hey, for our response for the product detail page, we want it to come back in 100 milliseconds. And it needs to call 5 services, but it's going to call them asynchronously because none of them really depends on the other. So let's say a timeout of 30 milliseconds because our system is super duper fast on each of these services, and we know that within 100 milliseconds, or maybe 80 or 70 or 80, we should get our response back. But then for some reason, the rating server is under a lot of load, and maybe you build it in MongoDB, and MongoDB is acting up. So you say maybe it's going to take 200 milliseconds to respond this time. So instead of having all the other services wait for it for that 200 milliseconds, you say, hey, let's return what we have now, and then the gateway could retry and try and fetch the data after that, after it has fetched the other data for the rest of the services. Circuit breakers work in a way that when you, let's say you have a bunch of requests, and for some reason you see that maybe somebody is trying to DDoS you, or for some reason a client is making too many requests to a particular service, or the system is under pressure, you could neatly close off one of the downstream calls to upstream calls to a service, and then have it back up again when things are back to normal. And then fallbacks, you could have a system where you have some sort of redundancy. Maybe you have a service for users that presents user information, that presents a cached form of user information for the pages that don't really need high precision. Let's say for the home page or the products page, you want to display the user first name. Hi, this is Omoloro's page, and he has 5 items in his cart, and he has been a user since the 1st of May 2014. And then for some reason that service goes down, you may have a more detailed customer service that has actual details on the user, and then you could be able to say, hey, if this service is messing up for some reason, fall back and call this service. It maybe has stiller data or slower data, but it has the data, and you present that. And then proper caching strategies. There's this common joke that there are 2 problems in computer science, or the two major problems in computer science are naming, caching, and off-by-1 errors. So caching is a very, very big problem, and I'm sure anybody who's had to work with systems that had to scale and cache and all that for a while will testify to hours spent troubleshooting and debugging, and they find out it was a cache gone rogue, or I saw something in cache that was messed up. But if we have a gateway, then it's possible to centralize our caching and do our caching, maybe have a caching for entire responses, caching for sub-responses from requests and all that. Just makes it easier to handle these things. So I'll go ahead and give a small demo of what an API gateway will do. I actually have this on GitHub, a demo on this. It was with the FileCore protocol built by Netflix. I'll talk a bit about that later on. So let's assume we have this service here, the user service, and then it's called, because we've broken down into microservices completely. So superdupermall.com.ng has subdomains for each of the microservices. So this is the customer's subdomain. And then it just gives very, very simple information: the user ID of the customer, first name, last name, date of birth, and then the status of the customer. So for customer 123, this is the information that it gives. And then for customer 124, it gives the information as well for that customer. And let's say we have another system, the wallet system, that shows the wallet balance of the user in Kobo, because people are using Paystack to pay, and then they say we should give it as a long in Kobo or something. And then the fraud risk of that customer, so we want to know if the person has been doing bad things on our site and whether to flag the person when the person tries to place an order. So just basic information. Of course, things are much more complicated than this, but just to illustrate what we're trying to do. So you could make a call to, let's say, api.spotify.more.com, which happens to be our API gateway, and request customers 1, 2, 3, and then it gives us a request from the two services, the username, of course, which will come with every request, first name, last name, and then the balance. So how to get this done in Falcor, I have it on GitHub. I will try to put something up that uses GraphQL for it, but yeah, this is just to give us an idea of what the API gateway will do. So a client that needs to display the user information, now instead of calling two services, is calling one, and then it could get much more interesting from there. But for this implementation that I have, you notice that there's no way of determining the fields that you're getting back, and that is one of the problems I mentioned earlier with mobile clients, is that you want to pay attention to the data you're using for the client. And to do that, you want to make sure that you're fetching as little data as possible to display whatever screen you need to display. So you want to make sure you're making as few requests as possible, and each request is getting the minimal data it needs to display what it needs to do. So let's imagine, let's track back a second to the user service and see, and let's say SuperDuperMore has now built an order management system, and that order management system needs detailed information on every user, because it doesn't just need the first name, last name, and date of birth. Now it needs to know the order history for that user, how many orders the user has placed, needs to know the next of kin, needs to know the address of the user when the orders want to get delivered to the user, and things like that. And let's say, for sake of argument, we put all that into the user service. For the product detail page to display the user name, hey, this is Omoloro's cart, it really doesn't need all that information. So it would be good to have a way where we say it's only the information that we actually need for this view that we are on that gets returned. So there's this, there are various tools that allow us to do that. There's GraphQL, there's Falcor, like I mentioned earlier, there's Zoo, another Netflix tool. Falcor and Zoo are by Netflix, and then Nginx Plus. I'll touch on Nginx Plus a bit for a few seconds. Sorry, we're a few minutes over time, but I think it's worth touching on. Nginx and Apache also, but I prefer doing this in Nginx, provides tools for extending itself. So if you have, you set up your Nginx config and you want to do cool things like, depending on the URL, you map to different servers, for instance, or you want to do some sort of A and B testing, you can do that with Nginx. Just write the correct, or extend the right phase in Nginx. You could do it in Lua. They released a JavaScript, kind of JavaScript library in September last year, but I'm not too confident in that because it's pretty new, and then I'm not really happy with the whole new JavaScript VM thing. Yeah, Lua does it pretty well. It's a very simple language to learn, very, very simple. So you could do that as well, and like group your requests together and do gateway-ish things. But this is GraphQL now, so the syntax is a bit more complicated from what we had before. So before we only had, we just made it simple. So all the work was being done on the gateway. But now I'm making the client do the work. I was saying, clients, for the user 1, 2, 3, I want to fetch the user ID, the first name, last name, and the wallet balance. So you give an identical request, but here you see that the client is the one doing the work. So what this does is that it frees up, it liberates the server side and the client as well. So the server doesn't have to start thinking of different scenarios for the what different clients will need. It doesn't have to say, okay, I want to have a product detail minimal page and then product detail extended page and all that. It doesn't care anymore. If this is implemented correctly, you could have a scenario where you only have a single endpoint for all your API requests, and based on the kinds of fields that get passed into it, the client gets the responses that they want back. So here, the user IDs and arguments, it's not strict JSON, as you can see. It's like a GraphQL syntax. It's, different people have different opinions about why it's not strict JSON, but then this is a request that's built, and if you just study it for a few seconds, it will come to you, and you see how easy and almost intuitive it becomes, and then you can use it to build whatever complex objects that you need to do. GraphQL also provides things like introspection, so you can view your entire schema, and then there are libraries around and projects around GraphQL. There's the Apollo project, which is worth looking at as well. So I'll touch on inter-service communication a bit. When you want to communicate between services, there's no hard and fast rule behind it, I insist. Some people say, hey, don't use REST to communicate between services, but in some use cases, REST is perfectly fine. In fact, in many use cases, REST is fine. So you want to know if your communication should be synchronous or asynchronous. For synchronous, imagine you're doing a checkout process and you need to check 2 or 3 different services to get the information. In that case, it is synchronous because you cannot say, I mean, if the customer does not have, if the payment doesn't go through, for instance, there's no point in maybe deducting the stock of the product or doing other things like that because payment did not go through. It's a transactional operation. I mean, the first 2 products are actually very similar because if it's transactional, then that will determine, I mean, to a large extent, well, maybe they're not so similar after all. For something like the product detail page, if you have what we described with ratings and the wish list and the basic product information, all of those things, none of them depends on the other. So you could when the gateway wants to fetch the information there, or if a service wants to aggregate that for maybe the order has been placed, you also have the user ID and you want to put all the information together so you can have a nice message to display on the label, for instance, that you want to ship the order with, that you don't need to necessarily have it synchronous. You could have asynchronous calls for that. They also want to know how secure you want the calls to be. Do you want to have an internal authentication kind of system, or will you just restrict things to your virtual private network? So some people prefer to have an API gateway, and then you have all your services restricted on the virtual private network, and then all communication to your system from the outside go through the API gateway. So you're sure that you don't need any other authentication apart from network layer communication, and you know that your systems are more or less secure. All right. So yeah, here I just listed a few things. You could create pub subsystems. So imagine a scenario where a new product gets created. There are several systems that need to know about it. The recommendation system needs to know about the product so you can start recommending it. The product system was probably created in the product system and the product service. So the product service will know about it. The stock service, if it exists separately, needs to know about it. The pricing service needs to know about the product and its prices. And yeah, you can imagine all the other systems that need to know. So and if something gets added to your cart, for instance, or checked out, several systems need to know about it. The stock system needs to know, the product information needs to know. Maybe wants to say, okay, this product has been sold 12 times, now it's been sold 13 times. So for such operations, you may want to consider an event-driven kind of system where you just publish things to a queue or to an event. Just publish it, and then anybody who's listening to that particular event, the carts.add event or the product created event, will perform the appropriate actions within the system. So for further reading on microservices, you can check out these guys. These guys are really doing awesome stuff. Netflix, ThoughtWorks, that's Martin Fowler's thing, and he's one of the guys who really started the whole talk about microservices again. Because it was around for a while, then he died and came up again. Uber is doing many interesting things. They have a few hundred microservices, if I'm not mistaken. Can't remember exactly, but yeah, Uber is doing interesting things with microservices as well. Amazon, SoundCloud, Konga in Nigeria here is using microservices. So check out microservices.io articles who is using microservices. The link is in the slide, and you can see detailed information on what they are doing. Netflix in particular provides lots of information on things that they are doing, things that they're about to do, and yeah, there's lots to learn and share from that. So with that, thank you very much for listening, and yeah, questions, and of course, don't forget to be awesome in all that you do. That's all for me. Questions, please. No questions.
I like your inclusion of Konga.
Thank you very much. Okay. Okay, I see a few questions
Laura,
here.
could you? Okay.
Okay, I see a few questions here from Mokasala. You say the microservice shouldn't depend on another microservice. How do you build
I
a
was going to
system
mention
of?
that. Yeah.
Okay.
So you could you like maybe answer that question with the pub sub thing? So what I was trying to say is, it should be it can use another microservice, but it shouldn't depend on the correctness of this service should not be hinged on the availability of another. So could you explain in context of the event-driven publishing and subscribing methods, the dependencies or the intercommunications between microservices? I was unable to answer that then due to
Okay.
my connection. Yeah.
Okay, so let's say, for example, you have a product system and you built it in Elasticsearch because you have all the product information as a single object. You have your cart, which is a collection of products, and then you have checkout. Now, checkout is different because you can't really do checkout. I wouldn't advise anybody to do anything that's transactional in an object-oriented kind of data store. So you're using traditional MySQL, all its optimizations, indexes, and all that. And you have maybe 4 or 5 tables that need to be notified when somebody checks out. And you want a response time where many people check out. They get their response immediately, and then they can do other things on your system. You don't want them to be tied down to that to check out. Or you don't want check out to be a bottleneck. And then let's say you're doing a Black Friday sale, for instance. You have 60,000 users on your site, and maybe 10,000 of them are trying to check out at the same time. My SQL will cough if it doesn't die. So if you have a queue, for instance, like you're using an event-driven system, you just push all your checkouts from you have a checkout service and you have, say, an order service. So when you check out, the order gets created in the order service. So instead of having the checkout call the order service and wait for a response that says, yes, HTTP 200, status success or status true, your order has been placed successfully, we just say when the order has been checked, when the checkout service has done all its computation and says that everything is fine, it pushes it to a queue and says, okay, publishes a series of events, pushes it to the queue, publishes it and says, this customer has placed an order for this product, this quantity, using this payment method. Then it sends, publishes events also that says, this product has been checked out. So then everybody that's listening says, hey, product ABC has been checked out. Let's increase the stock, let's increase the ratings, let's increase the sold count and all that. So that way, even if the order service goes down for a while, the checkout service cannot say that, hey, I cannot, the checkout service is not prevented from doing its actions. It can still continue to push things. When the order service comes back up, it just listens to all the entire backlog on the queue, and then it starts handling that from there. So, Toby, is that answer sufficient?
Yes, I believe that's exactly what I was looking for.
All right, cool. All right, is there anything else that's coming? Anything that we've missed? So there are a few things that I didn't mention, things like configuration management was the previous question. You have things like console for service discovery, things like Eureka. I mean, so many different interesting tools, and that's an entire topic on its own. I see a new question. Sorry, I saw a question pop up, but I can't find what question it is exactly. Please, if anybody here knows what question it is, can you read it out? Okay, microservices seem almost too good to be true. I've bought into the idea. However, I'd like to know if there are any downsides to developing applications this way, time, cost, technology, process, anything. So I think that was covered a bit by Ezra, a bit by Toby as well. I'll go over what they said again. First of all, you need a good development team to develop microservices because it's not a place where you go to and you try to start learning what single responsibility means or what independent deployability means. You have to know these things. And then you also need to have a fair understanding. To do microservices properly, the DevOps culture has to be strong. So the developers have to understand and be able to deploy their systems and know how their systems will behave in production, how to monitor and troubleshoot their systems, because it's not a sysadmin thing anymore. It's more like developers and sysadmins working together and even being interchangeable in some cases. So that's one of the cons to it. The other thing is how many is enough. So many companies start with a monolith. I think I read a story about a company that said, okay, we'll probably need about 6 microservices, and then the first year they had 2, a year later they had about 12, then the next year they had about maybe 80 or 90 microservices. And that's how it gets, because when you get into it, you realize how more and more things can be broken down into services. And then when that happens, yeah, it just makes sense to continue and to continue. And then you need a strong team to be able to maintain all those services. You need strong monitoring systems at that point, because it's no more about having somebody looking at a new relic or some other system and seeing a red spike and saying, hey, something is going wrong. You need to have ways of knowing that, okay, on this system something has gone wrong and we need to fix that. And yeah, monitoring becomes very, very important, and testing as well. So systems cannot go into production anymore. You just change an interface or change an endpoint, and then people are like, hey, something has gone wrong, and you say, oh no, sorry, we changed the spelling of cancel in the endpoint response, and then everybody is in a bad place. So all those things need to be taken into account. For costs, well, Docker has made it possible to not really have a large cost impact from having different services in different languages. So previously, where you'd be worried about, hey, if I have one in Go, or one in Java, and one in PHP, that's different server configurations. How am I going to handle that? With Docker, you can have different containers, and then there are tools like Kubernetes and other awesome things that you can use to manage that. But yeah, they're still. I mean, I can't even say for sure it's more expensive or cheaper, but it will depend on your implementation. I'm seeing a few other questions. Got to get to them. Also, in terms of timing, it's usually the first microservice is the longest to build. It takes a huge amount of time from experience. From what I've read, it takes a huge amount of time to build the first one. The second one, not so much time, and then progressively it becomes much easier. Then at some point, you can be building microservices in a week, 3 days, maybe sometimes even a day. So yeah, the first one, and then what to be mentioned about having base configurations, base repositories is very important. So you have a base node repository, base Java repository, base Go repository that has things like metrics injected into it already, login and all that, and then it becomes very, very trivial to set up a new service to do something.
There's a question on API Gateway. It says, how does using gateways affect implementation on the client level? Seeing the data response might vary based on the availability of the services being called.
Okay, so that's a very, very good question, and it's one that has evolving answers. So there's something that PowerCore does where if a particular service is down or doesn't give the right response, it specifies a kind of error object, and that's PowerCore as a protocol does that, and then the clients that use that know how to deal with that. But since many of the other systems, like GraphQL, for instance, is pretty much a query language, and with libraries around that, so you can use whatever system you want to build the gateway when you use GraphQL. So the whole team will have to decide on how they want to handle that. Do you want, say, nulls if a service cannot be responded? Do you want to flag some services as essential for some calls, so that if it's down, then the whole call is a failure? How do you want to do that? So once again, it's something that's very, very subjective. It's not a one-size-fits-all kind of thing. It's based on the use case, the kind of information that needs to be retrieved or sent, and what's going to happen with the response. So if you're okay with saying, with displaying placeholders initially and then eventually filling up with data when there's a retry that's successful, then fine. Then if not, yeah, you have to figure out how you want to deal with that. Is there any other question?
Yes, Goke has a question.
Okay.
Looking at the communication between microservices, all the implementations you mentioned seem like a single point of failure. I mean, if the API gateway is down, clients can't access any of the APIs. What strategies can we put in place to ensure failure?
Awesome question, and that goes back. I'll go back to Toby's slides again. I mentioned something that Toby talked about. Toby talked about how essential testing is for microservices. In fact, probably the most essential thing. So before anything goes into staging or when it goes into production, you want to be sure that it is completely tested, and then there'll be tests when it's deployed into production. When I think of single points of failure these days, I don't want to think of having deployed bad code. Somebody puts a wrong brace or something, and then it broke the entire code, closed the PHP brackets, and everything started breaking or something. I don't think of it that way anymore. We have build tools, we have automated testing. There are too many things that should prevent that kind of thing from happening in a system that's serious about implementing microservices. So let's not even talk about that. Let's talk about things like a server dying, for instance, and it happens. AWS is fairly reliable, but every once in a while, a server goes down, and ELB becomes inactive, and yeah, you don't know if things stop working. So my strategy that I propose, I haven't actually done it, but what I propose for systems like this is for things like API gateway, it shouldn't be in a single data center in a single availability zone. And by the way, it's usually advised that when you deploy microservices, you use a cloud system like AWS, maybe Azure, maybe Google Cloud. So the API gateway shouldn't be a single server or in a single availability zone, or a single ELB. It should be distributed across maybe 2, maybe 3 different data centers. That way, if one of them goes down for some reason, then you're able to take care of the load with the other ones, and then handle your routing and your handle the routing to the individual client services properly. So not really about somebody deploying something and it breaking, but more about things that we cannot control happening, but we have fallbacks, and this should happen to most of our systems anyway. Have things in different availability zones, have redundancy. Maybe one of them is 3 services, or something. The other one is 1. It doesn't have to be the same scale. You don't have to reach the same amount of traffic to both of them, but just have it in such a way that we are not relying on just on one physical system to handle that. Hope that kind of answers it.
Okay, so there's one last question, but I think that's for me. I'll just answer that real quick. Aziz Taiwo is asking for a light PHP framework. Even Laravel has a lightweight version. It's called Lumen. You should check it out. And I think EU also has a lightweight version. Most PHP frameworks have lightweight alternatives that are like strictly purely for APIs. I think I've used Falcon. I'm not sure if the Falcon I used was a lightweight. But,
yeah, there's Falcon Micro, so that's
there's a Falcon Micro. Yeah. So there are many alternatives. Most of these frameworks have the equivalent lightweight versions. Someone asked, how do you handle the issue of eventual consistency in microservices? I think it meant eventual inconsistencies in microservices.
No, I think it means eventual consistency, where you have maybe a distributed data store, and then you write to one, and then it has to be propagated to the different maybe slaves or maybe multiple masters in that kind of database cluster. Is that what yeah, that's probably what Webanji Jacob meant. So I think for microservices, I think it's managed the same way you would do for any other kind of system, because like I think Toby mentioned, every service must own its own data store. So you don't have 2 services writing to the same data store. It's a taboo. It shouldn't happen, because you want to know who is writing what, and you want to have a single form of control to the data store. So I mean, the exact same way you'd handle eventual consistency by using, say, Cassandra or whatever that database cluster you're using, the same way you would handle it is the same way you'd handle it in a microservice kind of system. Is there any other question?
I think that's it.
Okay, thank you. I don't think there's any other question. Omoloro, thank you very much.
Yeah, thanks a lot.
I really appreciate that. That was really very comprehensive. And because we are far behind time, we said we're going to finish like 3:30, and this 3:56 already. I think it was too interesting to go. Yeah. So thank you very much. Thank you, Ezra. Thank you, Toby.
Yeah.
So before we go, I just wanted to say 2 things. Just 2 quotes. One from DHH. It said, "Needless complexity will kill you faster than anything with a small thing." And I think that also refers to big teams too. So, and another one by Chad Fowler is on Microsoft. He said, "The older I get, the more I realize the biggest problem to solve in tech is to get people to stop making things harder than they have to be."
Okay, wait. Now this brings about a lot of conversations. You know, right?
Yes, I know.
Yes, actually, yeah.
You are trying to refer to microservices as being complex, or introducing complexity into the infrastructure.
Yeah, what I'm just trying to say is that you know at what point, you understand at what point where you need to introduce microservices. Microservices will not work for everybody. it won't work for everything. It won't work for every company, right? But the fact that you've heard about microservices today and tomorrow you just say, oh, you just go to your team and say during this stand-up or during the sprint, say, look here, guys, we are going to start using microservices as from today, without considering every other factor. It would be like a mistake. So what I'm just saying is that we should understand at what point you introduce microservices to your team, whether it is really essential or not. I think that's what I'm just saying.
I also have Jenny.
Actually had an anecdote of some sort that I wanted to give during my talk as well. Instances where basically, like you said, you just dive straight on into the old, oh yes, microservices, so we're going to use it, and then ultimately you realize it was the wrong decision to make, and then usually it's tough to even if you are so convinced, I know it takes quite some time before you recover from it, and then you'd have ended up wasting so much time, going all over the place doing, achieving nothing. So I totally agree with you when it comes to that point of needless complexity. Maybe next time I'll have an opportunity to share my story or something, but yeah.
Yeah, that's good, Ezra.
Okay, so we have Jenny on the call too.
Hi, everyone.
Hi.
Hi, Jenny.
Hi. I guess this is all for today. Any words from Ridwan?
No.
Right.
I mean, except thank you to everybody.
Yeah. Thanks for joining the call.
Yeah, so in June we're going to have like two forLoops meetup, one in Lagos and one in Abuja, which is going to be very interesting. And by the end of this call, all our speakers that had slides, they're going to upload their slides to Speaker Deck. So we are going to be sharing it with everybody so that you can have full access to everything that they've said, and also full access to the recording, because this Hangout was actually recorded, or it's being recorded at the moment. Yeah, so I think that's all. Ridwan, any other thing?
No. All
right, thank you very much, guys. I really appreciate it. This is great, and I'm sure we're going to have like more of these frequently and over time as we continue. Thank you very much, guys. Thanks for coming.
All right.
All right, cheers, guys.
Yeah.
Thanks. Bye.